Next up is Richard Rosecrance. He's a professor at the California State University, Chico. And today's presentation will be on olive nutrition. Thank you so much.
Great, great. All right, so welcome. I really like talking about nutrition, and in olives, it's quite easy. Olives are a very sustainable crop, and they don't need a whole lot of nutrients. In fact, they're a Goldilocks crop, which means that if you apply too little, it's not good, and if you apply too much, it's not good, just like Goldilocks with her oatmeal. So what I'm going to talk about today are 4 steps for a sound fertilizer program in olives. We'll talk a little bit about the soil reservoir, nutrient removal in the crop, and I'll show you a website where you can get that. Fertilizer timing to meet the demand for olive, monitoring techniques using leaf sampling and the importance of that. Then I'll focus on the 3 big nutrients that we apply in California: nitrogen, potassium, boron, and their deficiency symptoms and how to rectify that. And then briefly, if I have time, talk a little bit about foliar applications. So that's where we're going today. So briefly, let's again, what I want to talk about, developing a 4-step process for sound fertilizer management. 1, you have to evaluate the nutrient supply capacity of various soils because they do vary. You have to establish the crop nutrient removal from the current crop or to project the yield into the future, because you need to replace what is being removed in the crop. Otherwise, you're just mining the soil. And 3rd, you have to apply the amount of fertilizer that the soil is unable to provide to meet the crop needs. And finally, use leaf analysis to monitor the adequacy of the fertilizer program and fine-tune your applications. So I'm going to go into more detail, but this is where I'm going today. So let's first take a look at evaluating the nutrient supply capacity of various soils. And when we do that, you have to look first at the mineral pool, okay? And this is something that cannot be managed. This is just what the soil is, and it's dependent on whether it was a volcanic origin, marine origin, alluvial, if it's a very old soil like oxisol, or if it's a very young soil like entisol. Those provide various amounts of nutrients that are available as those weather. But these other nutrient available pools we can modify, and this is the exchangeable pool, and it's the fundamental determinant of native fertility, and that's the cation exchange capacity, and that's influenced by pH, salinity, and organic matter. And we can influence this by possibly increasing organic matter, which then can increase cation exchange capacity. And then the other pool is the soluble pool, and these are all nutrients must be in solution for uptake to occur. You can't take up zinc as a metal unless it's solubilized in water. And pH and moisture influence the solubility of various nutrients. And our goal here is just to provide enough for the crop and to minimize the amount of soluble nutrients that are leached below the root zone. This is not what we want to do. In order to do that, we have to have a very productive and healthy root system. And so to do that here, let me just show you this graph. Here we have percent root respiration on the y-axis increasing here. And what we see here is that most of the energy that's in a root is used for nutrient uptake. 65%, 25% is used for growth, and then 10% is used for maintenance. So a lot of energy is used for nutrient uptake to reduce the nitrate to ammonia and convert it to amino acids and take it up in the xylem phloem. Now, if you have a system like this on the right, where we have a waterlogged condition, this is absolutely anathema to olive production. Olives are very robust and they can live a long time, but the quickest way to kill an olive tree is to flood it. And what happens here is you stop respiration, you get anaerobic respiration, no nutrient uptake, no root growth, and the plant can die. So that's important. Another thing then is we have to establish the crop nutrient removal for the current or projected yield. And here we have, this is average California olive yield since 1920. This is, again, mostly table olive production here. And we see that our yields are, bounce around 3 tons per acre. But one of the things that you do see it, and sometimes it's very difficult to quantify your projected yield, is because of alternate bearing. These huge jumps from very low years to very high years, that's a consequence of alternate bearing. So trying to project your yields, can be difficult, particularly in an alternate bearing crop such as olive. But we do have calculators that are available here. If you just Google olive removal calculator, you can get to it here. Here's the website that I've developed here. And this is for a 5-ton crop, maybe a little bit more than we typically get on average in California. But what we can see here, this is for Arbusana, Arbequina, Cornici, and Manzanillo for nitrogen, elemental phosphorus, phosphate, elemental K, and potash. And for a 5-ton crop, we're moving about 32 pounds per acre in nitrogen, about 6 pounds of elemental phosphorus, about 98 pounds of K2O, or 81.4 pounds of potassium. So we're actually more potassium than nitrogen. So this will get you an idea on how much I need to apply based on what I'm removing, because again, this has to be applied to the soil. Another thing you might want to look at is nutrients in the prunings. Dr. Ferguson just gave a great presentation about pruning and hedging. Hopefully, those prunings will be returned back into the crop by shredding and applying that onto the soil down here. But some people could burn them and they might not be available. But if you look at an Arbequina hedge in California, if they are hedging, pretty much every year, there's not a whole lot of nutrients in the hedging material. There are some, but not a whole lot. In a Barnea in Australia, where they're doing more severe pruning, more amounts of nutrients are in the pruning. But you could include this in your nutrient budget or not, depending on how you're managing those prunings. If you're bringing it back into the soil, then you might not. But if you are burning it, then you might want to include these extra into your crop removal, the demand or requirement for the tree. So then we need to apply the amount of fertilizer that the soil is unable to provide to meet the crop demand. In California olive orchards, we're generally only concerned with the big 3 are nitrogen, potassium, and boron. And here we have a picture of a low-end crop. It's very pale in color. We get chlorotic leaves, lack of new growth, just a very weak growing plant. So if we want to apply these nutrients, where do we put the fertilizer? And in California, the way we manage them, most of the olives are in the upper foot of soil. Now, in some areas, I know people have said, oh, olives are very deep roots. And they do have some deep roots, but the majority of olive roots in California are in the top 2 feet of soil. And so if we want to do that, we want to apply it there on the surface. Nitrogen or boron can be broadcast or spread in the tree row. Best, of course, is fertigation. I'll talk a little bit about that. But because nitrogen and boron flow with the water, they flow in mass flow with the water, they can be more broadcast. In contrast, potassium does not flow with mass flow. Most of the potassium moves by diffusion to the root. And so therefore, we have to put the potassium very close to the root system. So Typically, we banned potassium in the wintertime right on the near the drip emitters or near at the edge of the alley where rain can absorb the potassium into the soil. So potassium you want to ban. If we look at nitrogen deficiency here, on the right we have a nitrogen sufficient crop. Over here, I'm sorry, on the left we have a nitrogen sufficient crop. On the right is a nitrogen deficient crop. No low nitrogen symptoms typically are manifested by small yellowish leaves, poor shoot growth, sporadic bloom, poor fruit set, generally not a very healthy looking tree. So when can the trees use nitrogen most efficiently? Typically, for the highest uptake by the tree, nitrogen should be applied to the root zone just before the period of greatest uptake. And that is typically when you get that first new flush of growth and flowering in olives. And so Luis had a great picture of the shoot here. And here we have the current year's growth right here in these leaf axils of last year's growth, because again, flowers are born on last year's production. These are the inflorescences, and they will turn into inflorescences later in time. And this is a very good time to start applying your fertilizer. And again, typically some of the most efficient way of getting your fertilizer in is through fertigation. And this is at California Olive Ranch, where they inject their nutrients right into the drip system. And that's very efficient because that's where the roots are growing, and the nutrients are solubilized. They stay solubilized longer. And so fertigation is really the way to go. So here's another graph here. This is some data from Australia, where we have nutrient uptake in kilograms per tree over the year from January to December. And what we see here, that nitrogen uptake occurs probably first in the season here, followed by potassium uptake, and then followed by phosphorus here. So typically, if we're going to apply nitrogen, we want to make sure you get that in March, because this is when the uptake is just before the greatest grand growth uptake of nitrogen into the crop here. And then potassium uptake occurs a little bit later. So again, just ahead of shoot growth and bloom in early spring. Now, you can get too much of a good thing, and so I do want to spend some time looking at that. Here we have some data from Israel, where we look at vegetative growth, yield, and quality at different leaf nitrogen levels. So here we have a variable, and this variable could be vegetative growth, yield, oil quality. And this is increasing, this is decreasing. And here we have leaf N level from 1% to 2.2%. What we see here is that vegetative growth can increase with N level up to a certain point. Yield can increase and then decrease. And I'll show you some more data that support that. But also, more importantly, oil quality. And the way we're quantifying oil quality, poor oil quality has a high level of free fatty acids and decreases in polyphenols. So oil quality, as measured by increase in free fatty acids and decrease in polyphenols, definitely decreases as you increase nitrogen applications and nitrogen in the leaves. So this is definitely why we don't want to apply too much nitrogen. Here's some data, again, from Israel, looking at problems with excess nitrogen. And this is, again, why I'm talking about how olive, compared to almond, pistachio, olives is a Goldilocks crop, where if you apply too little, you're hurt. And if you apply too much, you're hurt. Whereas in pistachio or almond, if you apply too much, the crop just doesn't take it up, and there's no detriment for applying over amounts of nitrogen, except of course, you're wasting money and you're leaching into groundwater, but there's no decrease in yield. Whereas in olive, there is. And so this is some data where over 5 years, 3 years of data between 2013 to 2016, where they applied either 0 or 40. Their oil yield was about 4 kilograms per tree. At 75 kilograms per hectare, they're up to 6. At 150, there was no difference. And then at 300, they had a decrease in yield. So again, you want to make sure you apply enough nitrogen, but not too much. There are other issues with excess nitrogen. Again, accumulation of nitrogen in the fruit negatively affects the natural antioxidants, the polyphenols, and it increases free fatty acids. Oxidative stability is changed, and bitterness is increased at high levels. So again, olive quality is decreased. Another thing, though, is that high levels or excess nitrogen decreases the ovule longevity and consequently the effective pollination period. So here we have an olive fruit. Here's the ovule right down there. High levels of nitrogen makes that ovule less receptive. It makes that cannot stay alive as long. So the longevity is longer. So the period that flower is receptive to pollen and it can be fertilized is less. You get less fruit set, you get less yield. So a lot of things why we need to be very careful about not over fertilizing our nitrogen. If we look at potassium, now I'm switching gears to potassium, some of the typical deficiency symptoms are dead leaf tips or on the margins, light green leaves, twig dieback. Sometimes you see a little boating of the leaves, and that's very typical of potassium deficiency. And here we have a good show of twig dieback and light green colors, particularly at the tips and margins. So ways that we can correct that is by, we can apply 10 to 20 pounds of potassium per tree or 500 to 1,000 pounds per acre in just one lump sum. Typically, you want to ring the tree or band it the drip line. Again, don't broadcast it because, again, the potassium doesn't move very far from where it's been applied. Typically, we want to apply it in the winter time, December to January, and let the rain move that potassium into the soil. And this can be good for several years. If you do a big dose, typically that could be good for a number of years. And here's some old data from Hartman here, where he had a mass dose of about 1,000 pounds. And then he looked at the average 4-year yield, and it was yielding 152 pounds per tree, very good. Whereas in unfertilized, they only got 36 pounds. And then he looked at the percent large fruit over the first, second, and third year, and it was pretty good at the first, second year, and then it started to drop off during the third year, whereas unfertilized were all very small fruit. So in terms of potassium deficiency, you get less crop and smaller fruit size, which in table olive is really difficult. You can't make any money on small fruit. Moving on to boron deficiency, another important one here. Typical deficiency symptoms are leaves with dead tips, a yellow band. You see that right there near the tip here, but still green at the base. So that is a characteristic of boron deficiency. Also, you get sort of excessive branching, sort of sometimes maybe like a witch's broom. You get twig dieback, but then you get this excessive branching too. So that's another example of boron deficiency. Now, if you look at boron deficiency in the fruit, you get a different type of symptom. Now, boron, the role of boron in plants is it helps the cells to elongate, to stretch, to get longer here. And if boron is lacking, then those cells do not stretch. They stay very compact, and you get this monkey face type of symptom where very defective. Again, this is definitely not marketable here. You get premature fruit drop and just not a marketable crop. Here we have another example of boron deficiency with, again, that monkey face. Again, boron is really important for cell elongation, cell extension here. And without that, the cells don't expand. They just sort of become necrotic and die. So correcting a boron deficiency, you can do this through soil applications, broadcasting 1/2 to 1 pound of a 14 to 20% borax material on the soil, 25 to 50 pounds per acre. Applying it winter, it would be a good time, and allow the rain to move it in. You can also, a lot of growers apply it foliarly prior to bloom, and that has proved to be successful as well. So foliar applications prior to bloom is also very good for boron. So in terms of the last step is using leaf analysis to monitor the adequacy of your fertilizer regime. And here we have just a stylized version of these nutrient concentrations where we have yield. This is percent of maximum, 100% up here. And here we have nutrient concentration increasing on the x-axis. And here, over here is the efficient zone, here's the marginal zone, adequate zone, and the toxic zone. And what we really want to shoot for is right up here, being adequate here, but not too adequate, and definitely not in toxic, because this is where we want to shoot for with our leaf analysis. And again, that's very easy to say, but sometimes hard to do. But that's what we're shooting for. If we look at the levels of leaf analysis for olive leaves, typically nitrogen is deficient at 1.4%, optimal is 1.5 to 2%. Potassium deficient is 0.4%, optimal is 0.8 and 1%. And boron is 14 parts per million deficient and 19 to 150 for optimal. Now, we have sort of been moving potassium, particularly in oil olives, this number up a little bit. Now, I've seen numbers around 0.7, 0.5% deficient. And so we'll stay tuned. We are looking at the potassium deficiency levels here in the future. Typically, the way we get that is we sample 100 mature leaves in July, and we take it from the middle of a non-fruiting shoot. It's very important to take it from a non-fruiting shoot, because a fruiting shoot will have much lower nutrient levels than a fruiting shoot. So finally here, maybe I'll briefly talk about foliar applications. Some people do it, some people don't. It can be a fast and effective method to supplement. I want to make sure you say supplement plant mineral nutrition to correct deficiencies, because you still want to apply nutrients to the soil. You just can't apply enough through the foliar applications. Olive leaves absorb foliar fertilizer fairly well, and I'm going to show you a caveat about that, but they cannot satisfy the full nutrient requirements. But they can come in, particularly like this year where we have a very wet, cold year. Putting on a foliar application may be useful because not a lot of root uptake is occurring because of the cold, wet weather. And in terms of urea gives good results at a concentration of 3 to 4%. Now, just to say that, olives are very drought tolerant. But one of the reasons why is they have these trichomes. So this is the underside of olive leaf. Here we have some of the stomata, and they have these sort of flower-like structures that can delay foliar applications here. still can get in here, but it might take longer than when you're foliar applying things to peaches or any kind of stone fruit. These trichomes can sort of slow down foliar uptake here. And here's another picture. So in conclusion, what I can say is olive is a very sustainable crop. They use, a half to a third of the nutrients that almonds and walnuts use. It's a Goldilocks crop for nitrogen and water applications. So you need to get right in that right zone here, not too little, but not too much here. Apply nutrients to meet the demand of the crop, and that can be based on what's removed in the crop, what's removed in the prunings. So that can help you to determine what the demand is, and use leaf analysis to assess nutrient status and to develop a fertilizer program. And one thing I should say about that leaf analysis, what's important here is not just to look at the levels here, but look at the trends. How are the trends changing over time? Are leaf analysis going up? Are they going down? Because that can be really important to help you modify or change your fertilizer regime. If they're going down, you might want to increase a little bit. If they're going up, you might want to say, okay, well, maybe I can reassess. And then soil analysis is used to diagnose excesses or imbalances, and that can be done every year if you want, or every couple years. So with that, I think I will stop.